So we're going to determine all values of x for which the following equations or inequalities are true. So you have 8 different equations here and inequalities here that we want to see what x values make them true. Now if you look at all these things, we have cube roots, half powers for square roots, fourth roots, just x's. And so we have to kind of understand those graphs. So if you look right here, you have the graph of the square root, which is the red one right there. You have the cube root, which is the blue one. And you have x, which is a straight line. And what you'll notice is, do you understand greater than 1? Do you notice that the x values are larger than the square root values, which are larger than the cube root values? Meaning, if I plugged, say, 8 into a cube root, 8's way over here, the cube root would be smaller than the square root, but the square root would be smaller than the x value that you plugged in. Or if you went over here and plugged in -1, they're all the same. The square root doesn't work over here in negatives. But if you put in -4, -4 the cube root would be smaller than -4 itself. Actually, sorry, I said that backwards. -4 is actually smaller. Remember, negatives get smaller as they go down. That's a little backwards thinking. If you plug numbers in between 0 and 1, do you see how the x value is actually smaller than the square root value, which is smaller than the cube root value? You can kind of see that very small, but the red line's in the middle. And so there's this comparison of at any given x value, how the cube root, square root, and the x value plug in all are related. And there's a relationship we want you to observe and see. And this graph can help. But in the end, you can simply use a calculator to crunch it. If you don't understand this graph, you can use a calculator. Now, with that said, look carefully. When you compare cube roots, square roots, and x values, do you notice that 1, 0, and 1 tend to have similar values? Can you see how they hit there? Nowhere else do they hit the same value. But at -1, 0, and 1, they do. Now, -1 doesn't work for a square root, which is obvious. That's why there's no red graph over here. But for the other two, they do hit out here as well. So this picture will help us understand. That's why I have this little picture right here, is this little interval right here. It shows us our -1s, 0s, and 1s are very important. And we're going to pay attention to values in between 0 and 1, in between -1 and 0, greater than 1, and less than -1. We're looking at those intervals and thinking about numbers in those intervals that make these statements true or false. And we're looking for the ones that make them true. But again, the key values are -1, 0, and 1, and the intervals between them. So let us try this problem. Let's think of an x value. When you cube root it, it's equal to the opposite of that x value cube rooted. So if we think about this graph, where does the blue graph equal the opposite of itself? Well, here, if I plugged in 1 to both of these, they would not be equal. The only place that this is equal to the opposite of itself, wouldn't it just be at 0? And just think about that. When x equals 0 is the only spot that if you plug 0 in, the only time you'd ever make it true. Every other number, if you think about the cube root blue graph right here, would not make any sense. Because again, a negative graph would flip-flop. Here's a visual of that. Again, a cube root looks like this. And here's 0, 0. The negative cube root looks like this. Do you see how they never equal each other except smack in the middle? Next, this one. When is the x value, plug in a number, equal to the square root of that number squared? Well, first of all, you know negatives are pointless because can you square root a negative? No. Can we ignore all negatives? So this whole side is gone. So all we're caring about is 0, 1, and in between these two intervals, somewhere in here and here. So let's check 0. Is 0 make sense for this? When x equals 0, would that be a true statement? Yeah. Okay, we got it. How about 1? How about 1? Would 1 work? Well, yeah, it does. Okay, 0 and 1 both work. Okay. If we plug them in, it makes sense. How about something bigger than 1? Let's try a number bigger than 1. Okay, so let's say we try 4. Is 4 equal to the square root of 4 squared?
Yes.
Well, yeah, that works. Okay, so we concluded 4. Okay, how about between 0 and 1? Can I put a half in? Is 1/2 equal to the square root of 1/2 squared? Well, yeah. So what are we coming up with? We're coming up with almost everything bigger than 0. So wouldn't anything that is greater than or equal to 0 make this true? All numbers greater than or equal to 0 make this true, just not negatives. Because if we try numbers in our intervals and on those specific spots, we see they work. Next, the fourth root of x equals the value inside. So the fourth root of what number equals the number inside? Well, let's first, can we throw out negatives? Because you can't take a fourth root of a negative. So all negatives go bye-bye. Okay, now let's think. Okay, let's try 0. Would 0 work? Do we have to cross that out? Would 0 work? Is the fourth root of 0 0? Oh, yeah, what? It does. Okay, how about 1? Does 1 work? Does the fourth root of 1 equal 1? Yeah. Okay, those two work. Okay, now let's plug in numbers in between. So, or let's just think about it. If I fourth root a number, will it equal to the number you're given? Do you guys know a fourth root looks very similar to this square root? It just has a different steepness to it. Think about that. Will the red graph ever equal the green graph? Will the red graph ever equal the green graph? It's a little bit sloped differently, but wouldn't they never make any sense? So guess what? We don't even have to check. If we just think about it, these are the only values that work because negatives don't make sense. And in between, they would never match. Now, if you want to, could you plug in like 4 or a number, 16, 1/2, and you'll slowly figure out they don't make sense. So basically, all you're doing is plugging in 0 and 1 and plug a number in between 0 and 1 or a number greater than 1 and see if any of those numbers or numbers in the interval are true. Next, the opposite of the square root of x equaling x. Okay, let's think of numbers. Okay, we always like to start with 0. 0 is very useful. Does 0 make sense? Is the square root of 0 the opposite of 0, 0? Does that equal 0? Yeah. How about 1? Would 1 work? The opposite of the square root of 1, no, that doesn't work. I can't take negatives. Aren't negatives go bye-bye? Okay, and then let's think. Okay, let's go back to here. Is there a number between 0 and 1 that you think would work? If you think of this graph, think of the green graph comparison to the red graph. Are they ever going to be equal if one's the opposite? Do you think they'd ever match except for at 0? And if you want to, you could plug a number in the middle here. You could plug a number outside here, and you would find that none of them make any sense. So the only number you can plug into this one would be 0. Everything else would be a false statement, and you can use a calculator to kind of play with it. Alrighty. When is a value smaller than its square root? Well, if we look at the graph, when is the green graph smaller than the red graph? Well, right here, isn't the green graph bigger? But isn't between 0 and 1, isn't the green graph below the red graph? So couldn't we say anything between 0 and 1 would be true? But would 0 and 1 work? Would 0 work? Is 0 less than 0? Is 1 less than 1? But is anything between 0 and 1, isn't the green graph smaller than the red graph? And yes, it is. So your answer will be values between 0 and 1. Now, you're like, I don't understand the graph. I can't remember that. Well, could you plug in numbers on your calculator between 0 and 1? Could you technically plug in a calculator and put in 0.5? If I did 0.5 on your calculator and see if the square root of 0.5, could you see on a calculator that that is true? And then could you also go and choose a number bigger, like say 4, and can you see that that is not true if you wanted to? So again, you can check 0 and 1, then you check between 0 and 1, then you check outside of 0 and 1, and you can quickly see what intervals or values work. Next, this is really a square root. I hope you understand that. So the moment I have a square root, are all negatives go bye-bye? So throw out all negatives. So would 0 work? Is the square root of 0 less than the cube root of 0? Nope. Okay, how about 1? Is the square root of 1 less than the cube root of 1? No. Could we check between 0 and 1? Can we check above 1? Could we look at the graph? When is the square root graph below the cube root graph? Well, is the square root graph above or below the cube root? Isn't it above? Isn't here where the square root graph is above the cube root graph? Sorry, isn't the cube root graph above the square root graph right there? So what that means is we have another from 0 to 1. And if you don't I can't remember my graph, plug in numbers. If you simply plugged in numbers and did the square root of, say, 1/2, you will find that that is less than the cube root of 1/2. It will work. And if you check a number bigger than 1, you will see that does not work. Next, when do we square a number? Is that less than or equal to the square root of that number? Well, would 0 work?
Yes.
Okay, so we can start off with 0 would work. How about 1? Is 1 squared less than or equal to 1?
Yes.
Yeah. How about -1? No, you can't put a negative in a square root. So we're stuck so far. So we know it's positive. So can we try between 0 and 1 or greater than 1? So let's try a number greater than 1. Let's try 4. Is 4 squared less than or equal to the square root of 4? No. That's a no. So I know something bigger than 1 doesn't make sense. Any number bigger than 1 will go, no. Okay, can we try something between 0 and 1?
Yes.
So let's try 0.5. Is 0.5 squared less than or equal to the square root of 0.5? And if you tried that on a calculator, it would be true. It would be true. So my answer actually becomes values between 0 and 1, including 0 and 1. So I now have to include my edges because the bigger than 1 doesn't make sense, but between does. I know this is weird for you, but if you tried your calculator, you would see this is actually a true statement. So last one, when is the value smaller than or equal to its cube root? Well, let's start with 0, -1, and all those. So at 0, would this be true? Is 0 less than or equal to this cube root of 0? Yeah. How about 1? Yeah. How about -1? Yeah, it does. All three work. If you think about it, if you crunch the numbers, they all three work. If you look at the graph here, aren't they equal for each of them? See how they're equal? The yellow dots? Okay, now, next. When is the value smaller than the cube root? So here, is the x, the value, smaller than the cube root in this interval? No. Well, is the x smaller than the cube root here? Yes, in that interval it is. How about here? Is the green smaller than the blue here? No, it's actually bigger. See, it's above. But here is the green smaller than there. Yes. So from the picture, we can quickly tell the answers are going to be between 0 and 1 and values from -infinity to -1. Those would be my answers from the graph. Because between here, the x value is smaller than the cube root, and here, the x value is below the cube root. Now, if you wanted to, could you simply plug in 1/2 here and here and see it? Could you plug in a -80, -20, -100? Could you do that and see they're true? So if you tried these on a calculator, you would also see they're true. Or you can just know it from the graph. So all this said, what numbers are we checking? -1s, 0s, and 1. And then from there, we check intervals. Values less than -1, values between here, or values bigger than 1. And those are going to help us find which values make these odd statements true.